All right, everyone. So, a couple more things. We kind of started with using Unity as a building tool, world building, laying out models and materials and lighting. Let's talk. I'm sure you guys hopefully talked about this in your 427, but let's talk about applying C# code in Unity. So, right now I have this is exercise 7 or sorry, 8. I have this world. It's basically a plane with a bunch of cylinders on it as such. Okay. I have this little floating red ball. Okay. I call it player over here in my hierarchy. And if I go to game mode, I'm going to hit play, which turns on my world or makes it active, whatever you want to call it. And I can't really do anything, right? So I got this world. It's not really interactive in any sense of the word. You know what I mean? This is interaction design, yet me touching my mouse or hitting a key on my keyboard isn't doing anything. So it's not interactive, right? So how do we do interactive things? Well, I'm going to go back to P5 real quick. I'm sure some of you are getting some anxiety for me just bringing this up, but let's, I'm going to make you remember back in P5, we would write code, right? All right, there's my square. And I've set up this variable x, which represents, in this case, the x position of the square, where it is on the board, so to speak. And then I'm just going to write a function, or I'm going to write an event function, event handler, I should say, like, I don't know, key pressed for us. There we go. And I'm going to say, okay, every time someone presses a key, let's change that x value to x plus 25. Okay. I'm going to run this. And, I'm causing some interactions, right? So in other words, this is P5, which is really JavaScript. I'm using that to set up variables, to run functions. This is a function. I'm using it to do event handlers. Event handlers handle things like key presses and all that kind of stuff. So we need to be able to do that in Unity. Now we can't use JavaScript, but instead we can do C#. Okay. So we could write C#, I can write you, me, anyone can write C#. Magical chat GBT consoles can write, C#, right? And I have some code here. It actually is going to work really well with Visual Studio Code. We're not going to really cover programming this week, but just know that like all of this is is that the right one? Yeah. This is some C# code, and I want to apply it to my world. Okay. I'm going to select the player. I go back to scene, and I'm going to click on the player. And I already have this code. I don't want to get too deep into it, but essentially the code allows me to use my cursor to move the uh, sphere left, right, forward, backwards. Now, right now, this is all of the information or things applied to this model. So I have a transform, which is where this exists in terms of position, rotation, scale. I also have a material here, which is the red material. What I'm going to do is actually add another component or another property to this model, and that property is going to be um, the ability to have the code applied. So I'm going to go to where it says add component. And I'm going to scroll down to where it says scripts, and I'm going to click where it says player move. Okay. And what's actually happened here is it's applied this script. Okay. Another way to do this besides clicking on the add component is I could literally take this code if it's available in my scripts panel, click and drag it, and you can see that also applied. Okay. So now that this code has been applied, I'm going to hit play. All right, and you can see now I can move forward, backwards, left, and right. Okay. this code is allowing it to do. It's also got what we call a public variable. The variable here is how fast my sphere is moving. Right now it's set to 3. I'm going to set it to 10, which is actually going to be a faster speed. And you can see that it's moving faster. Okay, so I can apply C#, I can move it around, or I can apply it. That'll affect my model. Maybe we'll talk a little more about C# on Wednesday's class. If I want to remove this component, just like any component, I can click in the top right and go to remove component, and that would remove that component. Okay. All right, let's talk about rigid body. Okay. I'm going to go, I have this world here. And here's how my world looks through the camera. Okay. Now, if I go to my game tab and hit play, nothing happens. Okay. I have these objects in my scene, but they pretty much just stay static. Okay. They're kind of like statues that just kind of hang there. I want them to follow the rules of physics. Okay. What do I mean by that? Well, in real life, if I have a penny, any object, and I'm on Earth and I let go, my object falls. Why does it fall? Because it has gravity. Okay. And then it will fall based on, physics, 9.8 meters a second. And, there's wind resistance if it was like a feather or something like that, right? So there's a lot of things that kind of go in. So what I'm trying to really do is I want to apply physics to one of the objects in my world. In this case, the red ball. Okay. So how am I going to do that? Well, remember we just talked about components, and one of those components we could apply was a script component. Well, there's another component called physics component. And more specifically, I'm going to apply something called rigid body. What rigid body does is it essentially applies physics. So now things like mass apply, things like gravity. Okay. So for instance, you'll notice here under rigid body that gravity's been turned on. So what that means is now when I hit play, because my object now corresponds to gravity, the ball falls and it hits the ground. Okay. Without that rigid body, my object would not correspond to physics. So if I were to just delete this or remove it, notice how when I turn this back on, nothing happens. Okay. You can also I like to use this and just literally type in rigid body. So that's going to allow me to have gravity. Now, actually, if I have two objects, I'm going to go over here and I'm going to do the same thing. Let's apply gravity here by applying the rigid body. And the results of that should be both the red and green ball are going to fall towards the Earth as such. Okay. Now, the gravity actually is based on your world, kind of like how gravity on Earth is based on the gravity of Earth. But if you were on a spaceship or the moon or another planet, your gravity would actually be different. So, we don't have the same gravity on Earth that happens on Jupiter or some other planet. So you can actually play around with gravity. What you can do is I'm going to go under I'm going to go under, where am I? Project set. I'm going to go under project settings. And what I'm going to do is go under where it says physics, right there. Physics/settings. Okay. At least on this newer version. Even older version, it's a little different. But actually, see under physics, it says gravity, and then it says y negative 9.8. Now, what does that mean? Well, remember that the y-axis is the up-down or the vertical axis, right? This is the y-axis. And a negative number would mean it falls, right? And that kind of makes sense. So it's like, okay, I have this object whatever it is, a penny or a can or whatever it is, if I let go of it, it's going to fall at 9.8 meters a second. If I wanted it to have less gravity, well, maybe instead of negative 9.8, we do negative, I don't know, 3. Okay. And I'm going to go back and let's do it again. Now it's still going to fall, but it's not going to fall as fast. Okay. So you can see this time it's a little slower. If I go back to my project settings, maybe instead of -3, we do -20, which would mean we have more gravity than normal. Okay. So you can see the objects fall faster than they did the first time. We could even do like change the direction. So right now my gravity is a negative number, but what if we did positive 9.8? What that would mean is instead of subtracting 9.8 from the y-axis every second, it would add 9.8 to the y-axis every second. In other words, it would go up. So the result, when this runs, this is actually going to move up, okay? So if you wanted a world where gravity was in reverse and things kind of floated up, you could do that if you want to do that. I'm going to set this gravity back to 0, and you can even do it from a different direction. So remember that y is the vertical direction. X would be the left, right, Z should be forward, backward. So if I did 9.8 here, and I do a play button here, what should happen? When this finally runs, is it should go to the right. Okay. If I did a negative 9.8, it would go to the left, so on and so on. I'm just going to make it like normal gravity. So let's change this back to negative 9. Okay. All right. Oops. All right. So I've set the gravity. Let's also talk about the concept of mass. Okay. So what I'm going to do is I'm going to apply gravity to this cube as such. Let's hit play. Oops. I guess I didn't change it. One thing is make sure you're out of edit mode anytime. Now what should happen is the cube is going to fall. And it's going to hit that other, actually, let me apply, I'm going to apply, I want to apply physics to this. You'll notice when that hit it, even though that had physics, it hit that sphere and it kind of bounced off like the sphere's made of like solid, bronze or something like that. It like didn't touch. So if an object has gravity but hits an object with no rigid body, it basically the other object won't do anything. Okay. You can actually even apply physics to something. Here, I'm going to apply a rigid body. I'm going to turn off the gravity here. So what I've actually done here is this will allow for physics, but not have gravity. You might say, well, what does that mean? Well, what it means is that if you collide with it, it will react, but it won't fall with the gravity of the scene. Okay. So what's going to happen is now that I've done that, okay, you can see how that kind of hit that object, right? Now, this is going to bring up another idea, which is the idea of mass. Okay, now what does that mean? Mass is how heavy or how much matter an object takes up. Okay, so I want you to think about, say, for instance, like a bus And I want you to think about, say, a bicycle. Okay. A bus typically, assuming it's a real bus and not like a toy bus, has much more mass than the bicycle does. Okay. So if a bike were to hit a bus, the bus will react, but not very much because the bus has much more mass than the bike does. If the bus hits the bike is going to get affected very much so because the bike has much less mass than the bus does. Okay. Now, you can actually you can set the mass of your objects. Right now, this is a mass of 1, and this is a mass of 1. So they're kind of equal. What I'm going to do is actually take this orange ball, and let's set the mass of that to 100. And I'm going to hit play. And what's going to happen is when the red cube hits it, it will react, but not as much because the ball, you can see that it is kind of affecting that, but not as much as before because this has so much more mass than that does. Okay. I'm going to change this around. Let me make this one. I'll make the cube 100. Now, same thing. This is kind of going to be what's going to happen. Like if a bus were to hit a bicycle, where it's like there's so much mass in the cube, it's going to really affect that orange ball a lot. Okay. All right, I'm going to turn off some of these items. I don't know why I can't turn these on. I'm just going to turn some of these off. All right, I got this, and oh, so what I'm going to do is I want to have this hit, and I'm just going to, let me turn this off. Just going to remove the rigid bodies for now. All right, I got this. And what's going to happen is it's going to hit the edge of this object, which doesn't have physics applied to it. So it's just going to like bounce off of it. So let's just kind of see that. Okay, so see how it kind of hit the edge and it tumbled? Let's do that one more time. Okay. Another thing we can kind of do is I'm going to select the cube here. And under the rigid body, we can actually apply what's called a constraint. What the constraint means is that you can tell an object that it can't, right now when this object falls, it's falling along the y-axis. And then it hits this and it kind of goes that way, right? Which I believe should be the x-axis. But what we could do is we could say, well, okay, the object can still fall on the y-axis, but I don't want it moving in the x-axis or in the z-axis, which would be going forward, okay? So we're putting a constraint on this. This is not something that would really happen in real physics, but let's just say for the sake of argument, we want to do this. Now, when I do this, and I were to play this, you can see it's not allowed to tumble to the right anymore because we've locked the x-axis there. Why would you want to do that? Well, maybe in a video game, you want something that just moves only up and down, but you still want it to be affected by physics or something. You could do something like that. Another thing we could do is we can freeze the rotation. When this hits, I deliberately have it so that it actually, besides moving in the X direction, it actually kind of rotates. It tumbles it, so it goes from you know, like this to this to this, upside down and all that. So that's rotation. So let's just say for the sake of argument, it can move, but I don't want it to rotate along the X or the Z axes, XI. Okay. See how it didn't rotate at all? Even before it kind of rotated like a little bit. Let's try it without rotating to the X direction. All right. So it can't rotate on the X. I think that's the Z actually. So let's change that to Z. There you go. Okay. So once again, it's like, maybe you have an object that you want to be able to maybe rotate this way, but not in terms of rotating it towards the camera or tumbling or anything like that. So if you wanted to, you could, restrict that placement there. Okay. All right. In the final video, I'm going to talk about physics material, and I'll also talk about colliders. Okay.